Hi guys, my name is Trevor Sullivan and welcome to another CBT Nuggets skill. In this skill, we are going to continue our learning about the Kubernetes platform, and in particular, we're going to be focusing on a feature known as network policy. Now, for the Certified Kubernetes Administrator or CKA exam, this topic is not necessarily called out in the overview guide for the exam. However, this is a really good feature to know pertaining to networking and security within a Kubernetes cluster. Now, you might be familiar with the networking model in Kubernetes clusters so far, which is basically that you have a pod network that is entirely flat. So your cluster has an internal IP address block that's used to delegate IP addresses to your pods that you deploy onto your cluster. And then all of those pods are essentially able to communicate with each other. So you might have one pod that's a database server, another pod that's a web server, another pod that's maybe running something like a Redis cache, and you can have all these pods that communicate with each other in order to build a complete application. Now, in order to create an application, that's a really good thing, to have that just inherent network connectivity between all of your pods that are running within your cluster. It makes things simple. You don't have to worry about setting up firewall rules or NAT rules or things of that nature just to get your web application to talk to your database server, just as an example. Now, the issue comes up when you're starting to deal with the topic of security within your Kubernetes cluster. So imagine that you've got maybe 20 different development teams, and they're all deploying applications onto a single Kubernetes cluster, perhaps in different namespaces just for kind of segmentation purposes. But if the applications that each of those development teams is deploying onto that cluster is able to communicate with all of the other applications on that cluster, well, that means that if one of those applications were to become compromised by an attacker, a malicious user out there on the internet who's able to use some kind of exploit to gain access or unauthorized access to one of those application components, then the attackers now have access to all of the other pods that are running within your Kubernetes cluster. So that means that they could automatically start attacking other database instances that are running on the same cluster. They can take advantage of exploits in other applications that are running in the same cluster as well. And that can create some serious concerns about the overall security and the attack surface of your organization's applications. Now, this is where the network policies feature really comes into play, because network policies allow you to control traffic flow at the IP and port level. So we're talking about basically layer 3 and layer 4 on the OSI model, either at the IP layer 3 tier, as well as defining ports, TCP or UDP ports, which would be layer 4, above, one step above the IP layer. And this allows us to control which pods are able to communicate with other pods within a Kubernetes cluster. Now, there's a few different ways that we can determine which pods are going to be allowed to communicate with a particular network port on other pods. And those three identifiers are going to be things like pod labels. So you could say any pods that have a given label are then able to communicate with a different pod that has a different label on a specific port. So let's take MySQL, for example. MySQL server listens by default on TCP 3306. And if you spin up a MySQL container, I should say a pod with a single container running the MySQL daemon inside of that container, then you could assign a label to that MySQL pod and then allow other applications that have a specific label to communicate with TCP 3306 on that MySQL server daemon. And we'll take a look at a diagram that'll hopefully make this a little bit more clear. You can also delegate access to network ports based on the namespace that a pod belongs to. So if you have maybe a database's namespace and then maybe another namespace for web applications, then you could basically create a rule that says only applications that belong to the web applications namespace are allowed to communicate with the database pod that's running MySQL Server in a different namespace, perhaps called databases. That's another way. And then you can also do IP blocks or IP CIDR blocks. So you can say, I want any IP addresses in this range to have access to this particular network port. However, you can also create exceptions and basically blacklist specific blocks within a larger CIDR block and prevent access that way. So you have basically pod labels, namespaces, as well as IP-based blocks as well that allow you to control the flow of traffic within the cluster. Now, the clusters, if you're already familiar with the concept of services, where you have a service load balancer that can basically forward traffic to many different pods using what's known as a selector, the network policy resource essentially acts in the same fashion, where you can create what's known as a selector, which is just a label that you want to use to apply a particular policy to. So if you have a MySQL Server daemon running in a pod, and that has a label of like app equals MySQL Server, for example, then you can use that app equals MySQL Server label pair, the key value pair, to determine that a network policy should apply to that particular pod. So the network policy resource essentially looks like this down here. And keep in mind that this is just the built-in network policy resource. You can actually get container policy add-ons that, like Calico, for example, that allow you to define additional types of network policies that are kind of extensions to the core Kubernetes network policy resource. But this particular network policy here in the documentation for Kubernetes is specifically referring to the built-in type of network policy. If you wanted to use another extension, a third-party add-on to your Kubernetes cluster, then you would need to refer to that plugin's documentation, not the authoritative Kubernetes documentation, to understand how to use that particular feature. So this is essentially what the structure, the schema of one of these network policy resources looks like. So as is typical, you have the API version and the kind. And the API version, this is part of the networking API group. So we would specify that this is networking v1. And then the kind, the API resource type that we are deploying here, is called a network policy resource. And this is a standalone resource. You don't have to deploy any other resources in order to create a network policy. You can actually just go out into a namespace in your cluster and provision one of these network policy resources. So you don't have to worry about deploying any pods. You can actually just play around with these network policies, make sure that you understand the schema of them correctly, and then you can actually go ahead and apply them. And then, of course, under the metadata section here, we can deploy the network policy into a particular namespace. So if we wanted to apply a network policy to a MySQL Server pod running in a particular namespace, we could specify what that namespace of that target pod is right here. And then we can also give a name label to the network policy resource as well. So that's kind of all metadata related, so the API version, the kind, and the metadata, but then you've also got the spec section here that allows you to define the actual configuration of the network policy rule that you would like to create. And so what you're going to see here is that you have this property here called the pod selector. And the pod selector is the label pair that you want to use in order to apply a network policy to a particular pod or set of pods, any pods that match that particular label. So right down here under the match labels child property, you would set the key value pair of the label that you want to apply this policy to. You also have the policy types here. You have the options of ingress or egress, or you can specify both of those values as array elements. Now, based on ingress and egress, you actually have an ingress section and an egress section as well, depending on whether you are controlling network traffic that is outbound, that would be egress traffic, or inbound traffic to a pod, that would be your ingress traffic, not to be confused with an ingress resource, which is a totally separate concept. That's layer 7 based HTTP routing. And I have a separate skill that actually talks about ingress resources in Kubernetes, but this ingress and egress is specifically referring to layer 3 and layer 4 network traffic that is either going out from a pod or into a pod. So under the ingress section here, you can select the ports that you would like to allow inbound access to. You can specify that as an array, and each of those ports can be have a protocol of TCP or UDP, as well as a port number that you can specify. So in the case of like Redis, I think is what they're trying to do here. That would be port 6379. So a web application might need to communicate with a cache, an in-memory Redis cache. And so it's basically being authorized on port 6379 right here. And then the IP block, the namespace selector, and the pod selector, those are the three different options that you have in order to determine which pods are going to have inbound access on TCP 6379 in this particular example. And then same thing with egress here, only egress does not have the namespace selector or the pod selector, it only has an IP block. So you're basically able to control outbound traffic based on the target IP address that the network traffic is destined for. So really quickly, I put together a diagram here that kind of shows an example, a couple examples actually of ingress and egress traffic here. So imagine that we have a Kubernetes cluster, we've got a few master nodes and a few worker nodes here, and then we've got a namespace in that cluster here, and that's got a pod running a database engine. Let's pretend that that's going to be a MySQL database engine listening on port 3306 TCP, and let's say that we want to deploy a website. So we've got an internal, maybe a public-facing website that we'd like to deploy, and that website needs to retrieve data from this database here on TCP 3306. So by default, that traffic is actually going to be allowed, and we don't have to worry about explicitly allowing it. However, if we want to block other network traffic that is not authorized, then we do need to define a network policy that grants this particular service or this deployment here and all of its pods that belong to that deployment and, of course, replica set. We're going to have to basically ensure that they have explicit access to TCP 3306 on this pod down here. Now, right up here, I've got a label, role equals DB client. You could use whatever key value pair you'd like to, but that's basically going to identify the pods in this particular deployment. And then if we copy that down here, I could change the label for the actual target resource that we want to apply the policy to, and we could say, purpose equals DB server. And then we could use this label in our network policy to determine that the network policy itself should apply to this pod with this purpose equals DB server label. And then in the same network policy, we've got the section where we can determine which labeled pods are allowed to access this TCP 3306 on this target pod, and that's where we would specify the application's label, role equals DB client, or of course whatever key value pair you'd like to use. Now, if we were to deploy another application into the same namespace, and that application, let's say that a hacker kind of breached that application, we could actually prevent access to our database server. So we could actually protect our database server if this application, this internal application, doesn't need access to the database server by applying a network policy rule that only allows our authorized applications to have access to that database server. We can prevent any unauthorized applications and therefore any attackers who may gain access to those applications from having access to our database server, thereby securing it. So the network policy is a really useful resource for protecting inbound traffic. However, you can also apply it to outbound traffic as well. So imagine that both of these applications, these websites, needed to reach out to external resources. Maybe there's a server component in there that needs to make outbound requests to some API on the internet, maybe like a weather API or a satellite tracking API or something like that. You can limit the egress traffic as well. So you could say, well, I want this deployment over here called website. I want these pods in this website to be able to access a DNS server called 8.8.8.8. However, I want to block access to 8.8.4.4. And on the flip side, on this internal application over here, I would like those pods to only be able to access a DNS server called 8.8.4.4 and have the access to 8.8.8.8 be blocked. So that's kind of a contrived example because we're basically just, pinging two different public DNS servers on the internet that are provided by Google. But you get the idea here that we are able to create IP-based rules that block egress traffic from our application pods running in our cluster out to other resources as well. So in the next videos here, we're going to dive into an example of network policy and test it out and make sure that we understand how this feature works in Kubernetes. I hope this has been informative for you, and I'd like to thank you for viewing.